Welcome back from the break. I hope you're ready. In the previous session, we looked at Le Chatelier, what the principle says, and how to answer questions if we will do chemical equilibrium and when the equilibrium is disturbed. I would now like us to go into this session where we will now use Le Chatelier and look at the factors that change the equilibrium and also then show the S, R, F, E that we spoke about in the previous section. Remember, the S is for the stress, the R is the response, the F is which side or which reaction will be favored, and the E is the effect after equilibrium. So when we're going to apply Le Chatelier's principle, we must remember that we always start in a closed system, and the closed system is normally in chemical equilibrium. If the system is not in chemical equilibrium, we cannot apply Le Chatelier's principle. So Le Chatelier actually only comes in when a system has reached equilibrium and there is a stress on the system. So we will apply the stress to the system, and the first one that we will apply is the concentration. Right, so my stress here is an increase in concentration. Now what I'm going to do is I want us to work with an hypothetical reaction, and we need to now remember everything that we've done up to now in terms of using our balanced equation for Kc expression. Right, so we have 3A, 2Bs. I want you to note that my 2B is a solid. Then I've got 2C that's forming and 1D that's forming. I just want to remind you that this coefficients here becomes our exponents in Kc. And I just want to remind you again that when we work on the Kc on the constant, the equilibrium constant, we do not use liquid and solid as part of our expression. What's important now is this is a reversible reaction, and this delta H is negative is for our forward reaction. Please remember the enthalpy that's given on a reversible reaction always apply to the forward reaction, meaning the opposite is true for the reverse reaction. In this case, we have the enthalpy to be negative, meaning that my forward reaction is an exothermic reaction. And if my forward reaction is exothermic, then it basically means that my reverse reaction is endothermic. Right. The question is, what will happen if more A is added to the closed system? Now, if more A is added to the closed system, it basically means that the concentration of A is increased. Now, you are not supposed to use little arrows up and down as I do now. You need to write the words that the concentration of A is increased. Right. So now we're going to use our S, R, F, E to explain what's happening. So what is the stress? The stress for this system is an increase in the concentration of A, and according to Le Chatelier, the system reacts to decrease the concentration of A. Now, for the system to do that, it means it needs to use up A. And for it to use up A, it means it must use A to make more of C and D. What you need to realize is you need both A and B to make C and D. So what's going to happen now, the effect is we're going to now favor the forward reaction, because it's in favoring the forward reaction that we can get rid of this high concentration of A. A will be used to make more of C and D, so the effect will be that the concentration of D and C will increase. This is the effect after equilibrium. What will happen to Kc? Kc will remain constant. Why does it remain constant? Remember, Kc is only affected by temperature. Now we will look at another stress, again an increase in a concentration, but this time we will increase the product. So, what will happen if more C is added to the closed system? For starters, that will mean that my concentration of C will increase. What is the stress? The stress is a concentration of C that will increase. What will the system do according to Le Chatelier? The response will be the system will react to try to decrease the concentration of C. How will the system do that? Whenever you want to decrease a concentration, you need to use up some of that substance to decrease the concentration. So if we want to use some of C, then it basically means that we will favor the reverse reaction. And when the reverse reaction is favored, it means after equilibrium we will have more of A and we will have less of D. Why do we have less of D? Because when we had to use up C, we needed to use D to make A and B. So please keep that in mind. Right. What will happen if A is removed? Now, when we use the words A is removed, it doesn't mean that we're now going to take A and there's no more A. No, it just means that we take some of A out of the system. So what will happen? Firstly, your stress is a decrease in the concentration of A. What does that mean? That means the system now, to reinstate the equilibrium, the system will have to make more A. So the stress is a decrease in the concentration of A. The system will react and try to increase. So how will the system get more of the substance? It means that the system will have to make more of A. How will we make more of A? We need to now favor the reverse reaction. Because if we favor the reverse reaction, we will use C and D now to make more A. And if we have more A, we need to remember we've used C and D now, so the concentration of C and D will decrease after equilibrium is reinstated. That's the effect after the equilibrium. What will happen to Kc? Kc is only affected by temperature, so Kc will remain constant. This is a very important one, and this is one that they trick us in the exam where we make a mistake, an honest mistake. So the question is, what will happen if B is added? Now what we need to remember is B is a solid, and a solid does not take part in this equilibrium, so it will not have an effect on anything for the equilibrium. So the equilibrium is only affected by aqueous and gases. It's not affected by liquids and solids. This is important for you to remember. So, the next one that we will look at is what will happen if we start in a closed system and the system is in chemical equilibrium. What will happen if we apply a stress to the system, but this time we apply pressure? Now we spoke about pressure at an earlier stage when we spoke about the rates of reaction. We also said that pressure is inversely proportional to the volume. So as soon as there's a change in volume, it will affect our pressure. Pressure can only be affected in gases. It's only in gases that we get pressure. Just a reminder again, the pressure is affected by the change in volume. So if the volume is decreased and the number of moles remain the same, then it basically means that in this decreased volume, my increase there will be more. My pressure will then be increased. So what happened now is that number of moles is now in a smaller space, is confined to a smaller space. There's more collisions per unit time, and there's more effective collisions per unit time, so it will obviously increase the rate. But what we need to know is that a decrease in volume will increase our pressure. So we know that pressure is affected by the volume. As we said, an increase in volume will decrease the pressure, and a decrease in volume will increase the pressure. Right. A decrease in volume will increase the pressure. That is, the question now is, what will happen if the volume of the container is decreased? Right. You should now have in mind that the volume is inversely proportional to the pressure. An increase in pressure favors the reaction that produces the least number of moles. So when the volume is affected, when the volume is decreased, then if you look at C is equal to N over V, then it basically means that the system will try to make less number of moles. What's very important when we look at pressure is we need to go add the number of moles on both our reactant and our product side. Just remember, the solid is not part of our Kc expression. So on my left-hand side for my reactants, I have 2 moles. And on my right-hand side, I have 2 plus 1, which is 3 moles. So let's go look at what Schreff says. The disturbance or the stress was an increase in pressure. Remember, the volume was decreased. So the system's response is to react to lower the pressure by forming less number of moles of gas. So for us to have that, our least number of moles is this side, because this side we have 3. So the reverse reaction will be favored. And if the reverse reaction is favored, it means we will use C and D to make more of A. So Kc will remain the same. Kc is only affected by temperature. Now we move on to the third one, the third factor. There's only 3 factors that we're going to study, where we're going to look at what the effect of that disturbance will do. We've looked at concentration, we've looked at pressure, and now we are quickly going to look at temperature. Right. An increase in temperature always favors the endothermic reaction. The endothermic reaction is the reaction that uses or absorbs the energy. Secondly, a decrease in temperature will always favor the exothermic reaction. The exothermic reaction is again the reaction that produces energy. Remember, a change in temperature has got an effect on our Kc value. What you need to know is this is something that you need to study. Increase in temperature favors the endothermic. Decrease in temperature favors the exothermic reaction. Right. What will happen if the temperature is increased? Now we know the forward reaction in this case is exothermic, meaning that my reverse reaction, as I said earlier, is endothermic. So what will happen now is the forward reaction is our delta H, but because there is an increase in temperature, it will favor the endothermic reaction. So how will we answer it? The stress is an increase in temperature. What does an increase in temperature mean? That it will favor the endothermic reaction, the one that uses the energy. And in this case, it is my reverse reaction. So the system will react to try to decrease the temperature by favoring the endothermic reaction, in this case, as I said, the reverse reaction. And what will the effect be on C and D? If we favor the reverse reaction, it means that we will use C and D, and it will make more of A. Now, if we go and look at the increase of A and the decrease of C and D, and we link that and substitute that into Kc, we see our numerator is smaller than our denominator, meaning that Kc will have a value smaller than 1. And that brings us to the end of this session. Thank you for your time.